Hey, hello students. Yeah, remember last time you guys told me to make a video of lesson 5.3, so I'm just thought of making this video, okay? So let me go quickly on those examples. And what we learned is about main idea is to have a linear relationships with regression. Now, what does this mean is, of course, you understood the scatter plot. The problem is understanding what is coefficient of correlation and to describe the relationship between two quantities and all this regression line also between two variables and how to model this in the real life. Now, all this we have also understood the best fit line is through the scatter plot, the dots that you first draw, and which one would go. And we have used this example, even though this was an example also solved here. Uh, This example is weight and height. And remember in the class, all you guys were almost 12 of you, I think. I forgot how many. But then we use your height and weight, and we try to even graph the scatter plot of the height and the weight. So the height is this x-axis and the y. What the Pima Community College has, they try to show all this in the form of, they show this in the Google Sheet, but we are using the calculator straight away that you have now. So this was an example also I think we did last time. And those of you who are confused, begin with straight away the first example. I'll pull it on my packet that you have. So this is the packet that you have. And I think since we already did this, I'll start this for those of you who may get confused. Let me view this as full screen. Okay. So here, so this problem, before showing this, I think this is the one that I did in the class yesterday. So let me walk through this again. To, if in case you're confused, I'll spend little time here. Even those of you students who missed the class. So first thing is manually do, and then I will show also on the calculator. So manually, what we do is this is the the two variables that you see here is age of a child in months. So the first is the independent. This is the independent variable x, and the dependent variable the how many number of words in vocabulary. So a child with age of 12 months, or we can manually also do this way. So starting with, let's see, you can start with 10, 11, 12, 13, 14, okay, and the 16. 17, 18, like this. We have 18 is the maximum, 12. So I put these two lines, it means the x-axis is pulled to the left side. So it's as if like you only want to know from 10. And this one has a 5 and a 31. So I'm going to pull this also and start with, okay, no, I think we can start directly with, this is not needed. Now, Rebecca must be laughing. Okay. So this is, it's like 5, then 10, and 20, 30. Okay, so you can do this 20, 25, and then 30 and 35. And then go on plotting the point. The first one is 12 is 5. So the 12 is right here. And 5 is right. So this is the point. 12 is 5. See? And 13 is 9. So this is 13. And 9 will be somewhere here. See? This is 13 is 9. 16, we have two of them. 16 is 18. 18 will be, I think I missed 15 here. So this is, I missed a number here. I think I missed, this is 15. This is 20. This is 25. This is 30. And then 35. Okay. So, so this 16 is 18 is, will be 16 is here. Go up here. 18 will be somewhere here. So that dot will be right here. So this is this dot, and then again 16 also is 22. So 22 will be somewhere here. Hmm, that's another point. and 18 is 31. 31 will be, if this is 30, just little above, this is all the way there. Yes. So you get scatter plot already. So I'll take this off. We don't need this. So what you see is the scatter plot, and the good news is, in this case, as the numbers increase from the x increases. So this is 12 and the 13. So this 12 and 13. These numbers, they are increasing, and then to 18. So x increases. Right? What does, how does the number of vocabulary words the child learns also increases? And what does that mean is, in the beginning, see this? In the beginning, the child of age, use the child of age 12. So this 12, the first one, it knows, no, this is like this. So 12 is 5. Child, which is 12 months, knows 5. So 5. So these are the y-axis. So this is the y-axis. So this y-axis is number of vocabulary words. Okay, and this x-axis is age, age in months. So this is age in months. Okay, so as x increases, the y also increases. You can see the numbers. These numbers, they go from 5, then increase to 9 and 18 and 22. So this also increases. See, this also increases. And that's why we say as x increases, the y also increases. And that's why we say there is a positive correlation. So this word is very important. How to positive correlation. Now, whether this correlation is very strong or weak, so we need to use, is this correlation strong? And it looks like in this example, like this. See, I can draw a line through like this, see, and almost like which is also called a best fit line. Best fit line means you could draw many different lines also. So some of you may say, why can't you draw this way? Somebody will say, why can't you draw orange one like this? So a lot of options are there, but the best fit line is called regression line. So what is regression line? Is basically the mathematician Carl Pearson. He was the one who did the study on least. This is called least square method. Now, what is that least square method means? It's like he was trying to see how far. It means, let me wipe this off. And we will find this in the calculator also and if you figure out what is that. Just wanted to share with you this. What does that least square Carl Pearson's coefficient of correlation using least square method? So what does this square method basically means? Let me write to this. So I know some of you, at least 2, 3 students would like to know why least square, right? So what it does is, so suppose these dots are like this. Remember, I had some dot, but I'm using some dot like this. One dot here, maybe one dot here, another dot here, another dot here, another dot here, and so like this, it could be a scatter plot. So what we do is, and I want to draw a best fit line. So which would be the best among this? I'll draw this, and you can see one of the points is already on the this one is already up. But the second one is little uppish. So you want to draw a square like this. So you draw, see how far away from. This is the approximate value. This is the actual value of maybe y2, the second number. This is y1, right? So this is there is some uh, difference between this one is approximate, right? Approximate basically means it is not the actual, but this is the actual. So you'll see there is a distance. So you try to draw whatever the same distance, try to draw a square. Okay? Same thing we could do here also. you try to draw a square like this. Same thing, we could see this also, and draw a square. Same thing like this. So this is what that meaning of. So you're adding the area of this square. So this area, this area, this area. Okay. Uh, so and that area you want to have the smallest. You want to have the sum of these areas. You want to make it the smallest of this, and that's why it is called least square method. Okay, now that you've gotten some idea about which is the best language, you want to avoid this squares to become big. You want to be area to be the lowest. So we have a formula. So let's go directly to this problem. So what does calculator does is there is meaning of correlation coefficient. So what is correlation coefficient? Now, what is that? Is it is denoted by R, and this R actual formula is it is covariance of variance of x and y, okay, and divide by standard deviation of x times in the square root times standard deviation of y. Now, you may get confused. What is this? This is for Sx stand for standard deviation means standard deviation. So how much is the spread of the variable from the mean? So what they do is we take the square root and you take the difference from the mean x minus x bar. X bar is the mean, and then you divide by n. Now, if the same thing is population, if you consider the whole population means everyone, then they use sigma x. So that's the difference. The only change is instead of this down is n minus 1. What you get is, suppose I forgot this square, so you have to see this x minus x bar. So this formula ends up to get, I don't want to go detail, I may make a separate video on this, why it is. So this formula now, the coefficient of correlation it is summation of x minus x bar, and then so it's a product of uh, difference of all the variables from the mean of x and y, and that's what that covariance. And the down is like see. So you can put this. See, this is n, and then this y minus y bar. If you don't get it, don't worry. We will do directly also. So what you end up getting is when you do work this out. Okay, and then what? Then there is a big proof here how this whole thing after that reduces to is n and summation of x y. So you multiply these two, then it is summation of x multiply summation of y, and then divide by put under the same square root like this. So, and then it is n summation of x square minus summation of x the whole square, and n summation of y square minus summation of y the whole square. All this is taken care, and you see this answer at the most between -1 and +1. The value always is between this, and if it is positive, we say positive correlation. If the number is uh, it depends on if you have 0, let's see, if your number is between -5, minus 0 point, -5, okay, and it is like this, R and less than 0.5. So this is called a weak correlation. And if it is like can draw the line. So this is like 0, and this is 1, and this is -1. And if the value is here, this one, between -0 0.5 and plus 0. This is called weak correlation. Or if the number is here between 0.75 and -0.75, then it is called moderate. This is like moderate. But we are not in the PIMA, they don't use moderate. So either you say strong or weak. So if it is here, you say strong, weak. If the number is more than here, it is the number is between 0.75 and let's say equal and then less than equal to 1, this is called strong correlation. So these are the things that you need to know. Let's put this, you'll see this part is what the calculator does. So I'm going to focus more on the calculator. Even the Pima Community College textbook shows you a detailed work how to do. Let me show. If you see the textbook, where is that? Okay, look. So what does the Pima do is, uh, okay, these are the all things. This is like a strong correlation, which is negative going down. This is weak correlation, and you see this, there is no correlation. Now this is the formula that I was just showing you that we are not going to use, even though it is solved. So look at this, how now beautifully manually use all, these are the columns for x and y. But since the formula has, there is the x squared term here, there is, and then you have to add x's. So you have to have third column, which is square. So 12 times 12 is 144. 13 times 13 is 16. So like that. So you go on doing this. 16 times 16 is 256, like that. Or 5 times 5 is 25. 9 times 9 is 81, like that. And how did we get this 60 years? Multiplying the x and y. So this 2 you multiply, you get 60. This 13 times 9, you get 1. And then the bottom piece is sum. Sum is you're adding all this one, also this. And then you put in the formula, look at this. So you replace all this adding thing and get that. But we will do use our calculator and directly show. Let me show this. Okay, so let me see if I can pull out the calculator TI and put those values. So this will help those of you who missed the class. You have to know this. Okay, honestly, I don't want to know. So I have the whole calculator in front of me, and I'm gonna put those values. I wish I could take this separate and I'll take this off. We'll take this also off. Now what I'm going to do is take this out. So I have a separate and um, okay, so this is the problem, right? You can see this is on page, I think it's on page, you can check where it is. So even though the question here, this question is only asking you to find the correlation, if you can see this. It says find the correlation coefficient. Of course, we'll do everything. We'll do the scatter plots. We'll also find the standard deviation. We find the coefficient of correlation. All 6 parts in the same thing that you can understand. The first thing is, let me put the calculator off first. So you can see at the bottom here, it is on and off. So you click on first is, let me put second and put it off. Okay. So, I think it's already on. Anyway, you know this piece, I don't know. Okay. So next is we go to the stats. Can you see the stats? And then you will see edit. It means we need to put these numbers which are here, x's and the y's, and see if sometimes you may have some of the numbers stored here already before. Let's see, I'm just putting some number like this, see 8. In the next, I'll put 9 and scroll down 6 and something like this, okay? And then I go here and then let's say go up, up and right and put some number 10, scroll down like this. So if I have like this, and I don't want these numbers, I want to clear this, so you can't do from here. All you have to do is that and see the CLR list at 4, clear list. So you'll have to click 4, or you can see go down to 4 and enter. And then you have to put open parenthesis. There is that L1 at 1. See this one, blue color L1 here. So click second L1, then comma, then there's the L2 at 2. So you click second L2. This is the second column. List of second. L means list of second list, right? And then close it and enter and say everything is clear. And when you go back to stat and edit and it's nothing is there, right? Now let's fill this up with the age in X. So this part, this row and the column, this row, two rows, we'll have to put here. So first number is 12. So you can see this 12. So in the calculator, I'm gonna put 12, so 12, enter, and don't you can enter or you can scroll down. Then the next one is 13. So put 13, go down. Then next is 16, go down. Another 16, go down. And 18, okay. Then you and also go down means it has to show up in the. So we have five children. There are five of them whose ages are given. So I go up here and then go to the right and then put the next one. So the next one is 5, 9, 18, 22, 31. Right? 5, 9, 18, 22, and 31. So all the numbers are right. So done. So once this is done, we will try to do the scatter plot. Let's see the scatter plot. So what is the scatter plot? You can see here this STAT plot here, right here. So you have to, it's a blue color, right? So you have to click on this and here. And now I have, there are one, two, three plots here. See plot one, plot two, plot three, plot. Don't worry about the second, third, fourth. We are answered about the list L1 and L2. So the first plot, the first two columns. So just enter, so enter, and you can see it's on the, it's blinking, it's off here. Can you see this is off? So you have to make it, click on this so that it is on, so that you can see all this type of graphs here. So this graph is like, this is what the scatter plot is. The next is the line graph, histogram. These two are box plot and like that. So you go scroll down, and these are the two columns, list one and list two. That is the age. So this is the age in months of a child, and this is number of vocabulary words the child knows. So this one you can think of plus dots. So those are too small. I will stick to this square. Change. Okay, go down and you can change the color if you want. I'll just use the blue marker and I'll enter. Or at the same time, we have to also go to zoom. See this and go to the 9 all the way to stat plot or zoom stats. So if I enter, you can see already the dot. So that's the scatter plot which manually also we did. The next one we'll do is something called standard deviation and average and all. Let's learn that piece. And we will also write it here, hopefully. This one I'll make it bigger. Okay, so now go to the stat. So our goal is, okay, so we have two parts here. I hope I can write here. No. Okay, that's because, let's see if I can write here. Mm, Okay, I think I can write it. So now we want to find out what is the, so this is the x and this is the y, right? We want to know what is the arithmetic mean. So main thing is what is the arithmetic means or mean. So mean means the average. Mean is the average. So we want to know the right way to do is you add all five of them x1 plus x2 plus x3 plus x2 plus x5 and divide by 5. So these five numbers, so you can add them and divide by 5, you get the arithmetic mean. And same thing you could do. Now since we are using the calculator, mm, why is this not hearing? Okay. So what I'll do is uh, click on, okay, stat. This is stat, and then we will try to do go to the right for calc. And these are the two things. First one is one variable stat, two variable stats. See? So I'm going to use two variable stat because we'll get a lot of information from the because x and y we have. Okay. Only thing I doubt whether we get a standard deviation. So what I'm going to do is separately do only one variable and enter. So the first list I'm using, enter, and enter. And you can see all the information. The main thing is the first one. So you have x bar is mean is 15. Okay, that's all you want for me important. And I want you to think of that as x is the fourth one, 2.4, and I'll round it to two places. That's a standard deviation. So for me, this is the most important. Of course, we will also know if you go scroll down, there is this minimum. The smallest is the 12. That is quartile one, and that we will see this. Right now, you don't worry because I have not done that yet. So we are okay. So this one. Okay, so these are the only two things, and then let's go for the second one. Stat. Right click. Let's go to the first one only. Enter. But this time we want L1. So we click on second and here. Sorry, we'll click on second and L2. I think we'll clear that part and put second and L2. And go down, down, down. Enter. We can see this is for the second one. That the average of this piece. So this piece that you have, that's the why it's not letting me to write here. Okay. Why? Okay, here. Y bar is average of Y is 17 and the standard deviation of Y is 10 point and round it to 3.7. So these are the important numbers. The reason I'm showing this you is because when we want to find a coefficient, this is the formula we want to find coefficient of correlation. The R part actually coefficient of correlation is covariance. So this covariance of xy and divide by sx into sy. So standard is this is that this piece, this is that this piece, and covariance is I already showed you. Now I don't want it to break your head too much. So what is important right now is we got this piece. Now we want to find the coefficient of correlation. So that means what I have to do is let me take this off. Okay, so go to stat. So we got this four information very important. Now what is standard deviation means how far is the spread of this the age in the five children from the average. So 15 is the first, and this means standard deviation, how far away. And you can see this is 10. That means there's too much of spread. The second number they are spread too much, and this the top one are almost close to 17. Sorry, 15. But the bottom one, average is 17, but the minimum and the maximum, they are far away from 17. That's why I say standard deviation help us to know the consistency of the numbers, how far away clustered around a specific. Now we want to do the next is go second, and I want to know what is the coefficient of correlation, right? So if I want to know, we go to the second, two, okay, enter, and that should be L1, right? The first one, so I'll click on second, and this one, then go down, 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 enter, 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 and of course, so this gives you both. Yeah, I think we could instead of separately doing this gives you both the thing, but it does not give you the standard deviation. I mean, it does not give you coefficient of correlation here. So to find the coefficient of correlation, you may be wondering how to do this. Or you, if you want, you could use this formula. So this, the big formula, the creepy formula that, because you already know what are the values of x, summation x, this part, then you know x square, then you know solution of y square, and you also have xy. So you could put those numbers and you get the answer. But because of the time, we are going to do directly. Okay. Okay. So in your PIMA, they also already so this is the same problem, right? These are the ones we put on the calculator. This numbers, and I was talking about the mean here. See this 15x bar. So that's how you get it. You are adding this number, this number you add a top 5 and divide by 5, you get 15. See, then the second number you add all this here it is y bar. That's the average is 17, and you can see this 17 is right here also. Then the standard deviation Sx. So this is a formula. It's square root. All you do is the mean that you get, you subtract from each of these 12 minus 5, 13 minus, sorry, 12 minus 15, 13 minus 15, 16 minus 15, and you square them. Look at that. You add, and at the bottom you use the formula 5 minus 1. It means whatever how many numbers are there, you have to subtract 1. And that's how you get 2.5. Do the same thing for SY. The reason to do this is because when we want to find a regression line, we need to the slope. See, this is the formula y equals mx plus b. But how do you get slope is itself is coefficient of correlation. Sy divided by sx. This Sy you get it from here. This Sx you get it from here. And you may wonder where the heck this came from. Fine. That's our coefficient of correlation. Now this one uses the Google Sheets to get that. See this part? Minus 4.5. I mean, not this. The coefficient of correlation. You have to use the Google Sheets. I think this one is showing that. No. Okay. So we can do it right here. That's what I'm trying to say. All you do is go back to that, back to your this one, right? So So let me write this x bar. This numbers we know. This is important information I want to write. And the standard deviation is 2.405. So this is the for x, and the y bar is the mean of y is 17, and the standard deviation of is. So I'll have to scroll down 10 point. Can you see 10.37? So these are the main pieces that we need, and then you want to find our goal is to find, see this part, our goal is to find, we can use directly regression line. Watch. So click on the calc, go all the way, and there's a 4. Linear regression is this, and then enter, and L1 is the first one, then L2, then we also want whatever the equation that we get, we need to store this in the Y. How do you do? Is click on vars, then right click, and then enter, and then again enter. And that's where it is already stored. See, you go down and enter one more time. You get, and it doesn't show you the equation is already known. See this A part here, A is the slope, which is 4.16, and the B is the y-intercept is already. But because we don't have, there's some changes I have to do. Go to the mode, and you can see the stat wizard. It is on. Let me check. It's off. See, it's off. So I have to right click and make it on, and then do the same thing again. Everything. Linear regression. Enter. 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 Was right click and two enters. One, two, and there you go. And again enter, calculate, and you get that R part. So you get a 0.9843. So your answer is, let me write this. This is coefficient of 0.9, and I'm writing 98. So that's a very strong. So this is positive, or you can say strong, positive correlation. Okay. So because this number is almost close to 1, because remember your R has to be between. The more closer to 1 and -1, we can say strong correlation. A weak correlation would be if your number is minus 0.5, like this, with the R and plus 0. So if it is between this, actually it is 0.25. This is 0.25 minus 0.25, like this. Because the next one we can moderate as from 0.25 to 0.75 is moderate. Anything more than we can stop. Anyway, hope don't worry about too much. Just remember this part. So we got this piece correct. So 0.98. Remember this answer 0.98 is important. I'll close this and let's check where is that thing. Okay, here it is. Okay, so see this answer, the R is 0.98. There it is. See? So 0.98, that's how this number comes. And these are the values of standard deviations, and you get the slope. But we don't have to do this all this work because the calculator does the work for us. See? So the your answer now here is Y is, I don't know, how do I write? Let me see if I can write the equation. And I'll pick a new one. Okay, watch this. So, so the so the so the y is ax plus b, right? Now, so the answer is a is, you can see on the calculator it is minus 45.x plus, and the b is, sorry, it is y is 4.17 times x minus. So this is the regression lines. So regression line basically means best fit line, or the equation of, or we also call it's called a prediction equation. So what is prediction equation? Equation means you can predict for any x now, whatever the value is. Suppose x is 15, we can just plug it in and find out the how many the if the child is 15 age of 15 months, then we can just plug it in on the calculator and find out what is that answer. And we will see this directly also. So this is called prediction equation. And there is interpolation, and you also have to know two more things about. I'm talking about. And there was one more thing. Okay, let's do one more. Okay, now not over. Now another last part is all this you are supposed to write on your paper. Remember? And this r square is called variance of x. This variance. So that's the variance of without the square root sign. Hmm. Okay. Now what we do next is we want to graph also. We want to know what is the graph. This equation is already loaded there, and directly say graph. Click graph, and you can see the line passing through. And then this is the batch fit line. It's also called regression line. And you can see these are the not actual number, but anything on the line will be uh, predicted one. Let's trace this. See, all the numbers could be traced. 12 was 5, 13 was 9. See, like this. Okay. And then if you want to find, we can calculate now any second and just put some number, 15, let's see, value. Okay. And just put 15. If the child was age 15 and you enter, and that's how. Of course, that one is there. Let's take 14 because there was no 14. So second put 14. I think I made a mistake. It should be 14. One time. And you see, that's like almost 12.8. That's like 13 vocabulary words. That's what it means. So I hope anything that you take between, when you trace, remember, when you trace, I go back, starts with 12, right? That's the minimum. And ends with 17, 18. So any number x between 12 to 18 will be your interpolation. That's called interpolation between the range of 5 to 18. And if it is outside, that will be uh, extrapolation. Now, since we did already this one problem, let's take another one. So please go to the, let me delete this. I'm gonna keep this somewhere here. And now we go to, so the one that we did was this one. Let's take one example and really get this piece correct. And straight away go to, now these are two big numbers. Still we can do this. Let's do this big number. Okay. Okay. Let me clear. So height and the weight we did. Then we can see some another example with different. Okay. Third exam and the fourth. Let's do this piece. So this is to better understand a linear regression line, look at another example, 11. So there are 11 students who answer third exam. Their scores are given, and also their final exam score is given. So what you do is let's plug it this quickly, and to save time, I'm gonna do it right in front of you so that you get it. Let me clear everything. How do we clear? Stat, go down, clear, okay. Open parenthesis, second, L1, comma, second, L2, close it, enter. So everything is gone. I think I messed up somewhere. Let's see where I messed up. Right? If anything is comes error, always click second mode. Get, oh, look at that. I can bring it back again and okay, go up and enter. So you get back the same. And then this is the one I made a mistake, so I'll go there. I forgot to put this as L1. So second and like you see. And right click, and enter, and you can see now it is done. So when you go to the stat and click enter, you see there's nothing here. And now is the time, let's put the number. What is the first number? 65 and 67 and 71. 71, there are two. Okay, I think I forgot to put this as 65. 71 twice, 66, 75, 67, 70, 71, 69, 69. So let's take care of all those things. And then you go all the way, go up, right click, okay. And the number is 175, 133, 185, 163, 126, 198, 153, 163, 159, 151, 159. If you make a mistake, you can see count also. You will see the if you sit down, then so that's where it start 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 of them. I may made a mistake. Check. Okay, I'm just trying. So you can see there are 11 here. Now, first step, scatter plot. Remember what is the first thing? So stat plots here. So click on second this, and also, these are the first two. Enter, enter. It's already there. This one, enter, and it's already on. So I'm gonna go enter, enter. I mean, scroll down, 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 and I think yeah, and enter. Okay, and now zoom in 9 because you have to do the stat, right? I'll go click on 9 and see this is all it shows up. And it's not doesn't look like a good. This is positive. Looks like it's going up from the bottom up, but they are not much in a line. Maybe it is. We'll see how much is a coefficient of correlation. To find that, remember the straight away we go to uh, regression line that will help us and coefficient of correlation. So how do we do that? Straight away with one step. To click on stat and then you go right and linear. We go directly to linear regression there. And you can say L1 and L2. This is where we want to store. So was again right click, enter, then again enter. So it is already stored there. Go down, calculate, and you got all your answers. So your answer is for A is replaced by, so I think, let me write the, so what is expected to write is your scatter plot you have to plot manually. Mm. And then you enter this regression line and coefficient of correlation. You are there. So let me use this. Okay, so your answer is what? Y is AX plus B. A is 4.7. Sometimes they ask you to write four places also. So I'll write four places. So 6, 6. But there's a 9 there. So 9 will become, this will be 6 and then 0. See, this is 4 times X. And the B is minus 1, 6, 9, 1, 3, 0, and 6. So this is 4 place. 1, 2. Okay. So that's called a regression line. So what is that coefficient of correlation? There R, and R is from the calculator. You can see it is 0.70. And this is actually I will call it like a moderate. Now why I call it this is moderate? Because this is less than 0.75. Anything more than will be strong. This is not strong. This is a little weak. I will not call it weak here. Let's moderate correlation. Okay, and that's it. And then once we are done this, all you do is we have to graph it also, right? And to graph it, just click graph it, and then there's the lines. It's already done for you. So all you do is, let's see, if I was a student, I want to graph this, and these are my numbers. Let's see if I do like this, and then you have those plots on your paper. So it starts with minus 169. We don't know, but it is zero. So if x is zero, you get minus 169. Yes, so what I'm trying to say is, so the equation is there, because this one, if you see, you may be wondering what is the x-axis and the y-axis. What they did is they pulled this. I mean, they try to pull this left. So if you click on the window, it shows you this part. See, 64 and 76. That's because if you see here, that 64 is right here is 65 and 69 is the maximum. So the calculator does the job for us. And the minimum here is, I think it is 126. Mm. So it starts at, there is 113 here. So it starts at 110. 210 is the highest here. So in this case, maybe 200, there's no 200. I think it is 175 is the big one. Oh, sorry, 190. So they took it 210. So that's what it is. So don't worry about the graph part. But the main idea is, once you have a graph, how do you find the value? Second and calc. Let's see, a student got an enter. And so the question is asked here. Can you predict the final exam of a random student if you know the third exam? That means, suppose the third exam a student gets, it doesn't show this. Let's see, we can put some number 69. This is 69. We have to put something in between only. So 71, 73. Let's put 73. If a student got 73 score in the third test, then final exam, how much he would get, and you can predict. See, he would get 179. Now you can't. This is called interpolation. So you're taking a number within this x65 only from here to here. Anything outside, let's see if you are taking a number bigger than that. If I want to do second calc, okay, so I want to write, sorry, click on trace value, and I want to write 74. Let's see if a student gets 74. Even the answer gives you 180. That's called extrapolation. So it is, that's because your 74 is outside. Oh, we have 75. Maybe I made a mistake here. I have to take something 80. Is there 80 there? No. Huh? So let's put a number, trace, enter. Sorry, I made a mistake. Yeah. First, I have to go to zoom and make it stat plot 9. This is our regular one. And please trace and put 80. Sorry, you have a graph. So second calc value 80 and enter. So I think I'm making a mistake here. Let's check. Second mode to clear this. Mm, Here you have this one. And I want to find the value. This one. Enter. And I want to put 80. Use the function variable is not valid. Okay, now if you see this, uh, what is this? So if you see the first row 65 and the big one is 75, right? So the minimum is 65 and the maximum is 71. So if you try to find a value second and calc like this and put a 80, which is big number, and you will see if I put 80 and enter, it will say error. So how do I get this? That's because of the statistics thing. It is outside, but we can still find out by using table set, and there is a table. Do you see this table set here? So TPLSET, so second table set. And you want to know because it starts with 65, you can type in 61 also, doesn't matter, starting, or 62. Just put some number which is a 62. I'll take because in your the first row here, 65 is the smallest. I'll start with 62 and go down. And here there's auto and there's ask. So I want to ask, make it ask so that you can plug in. And then it says dependent gives you direct answer. Okay, so enter, that takes care of that. And then click on this second, and there's a table. See, so there's a table. I'm clearing this. And now you can put 81 and enter. So you get the answer. Put 85, enter, and you get. But these are outside extrapolation because these are not the actual numbers. So when you graph here and do second calc and find a value and put 85, it won't give you, it will give you error. Okay, because it is outside. So I hope that also helps you to know what is the meaning of this table set and table also. So a lot of stuff you are already learning here about trace, graph, table set, stat plot, and I also showed you insert, statistics in maths. Okay, all this, then alpha, and this gives you fraction. If you click here and here, that gives you the uh, y. Let's go. I mean that's that part. Let me take another example. I still have time. 1 hour passed. So uh, let's do one more and go straight away to the example number. Okay, so here they give you some info. So the regression line is given all, and it's asking you the data ranging from 2 to 14 hours of music practice and whatever. What would you predict the score in math test who practices for 5 hours? So just put X is 5 here and you get the answer here. Not a big deal, right? I will go directly to some questions on this one. Before I go to 1 and 2, I really want to do one more on this one. Let's do this last one, 9. Let's do 9. Let me go back to the calculator. Let's clear everything. We don't want the old ones. Stat. Oh, if anything, if any error shows up, click second. This goes. Everything. So here it is. And then stat. Then we go down to clear the list. Enter. Put open parenthesis. Then second and go all the way to L1. Then comma. Then second all the way to L2 and close it, and everything clears. Then we go to stat and edit, enter, and put the numbers, and you can see the numbers are 1 to 1 3 5 7 9. So 1 3 5 7 and 9, and the next numbers are 9 6 6. So it is 9 6 6 4 and 2. Okay. And now we want to know scatter plot, and you already know second this, and it's already there for you, L1 L2. Yeah, first one, and enter. You can see it's already on. Enter, 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 and zoom, and you can see that 9 zoom stat. You can see the already. So this is what you have to manually do on your paper here. So this is where you graph this. Okay, put this number on the x-axis, y, and after that we need to find the coefficient of correlation. So straight away go to set and calc. Go down to linear regression, and this is the thing that gives you directly L1, L2. You need to store this, the vars, then right click enter twice, one more time, thrice, and get the answer. All these answers are there, and you get answer. You can see the, so the linear regression line. So we have y is ax plus b, and in the calculator, your a is the slope, is and plus the b is 9.4. We're done. So now we don't here it does not mean what does each time the value of x what does this means is minus 0.8 over mhm, minus 0.1 over 1. This is actually the slope, right? So basically what this means every time you increase x, if x increases by 1, x, then the I don't know why this is happening. So this means the y decreases. So minus means the y decreases by 0.8. So that's the understanding of the slope. Uh, and that's it. Yeah. So one more thing we have to show is the graph of this, right? So we need to, uh, I think when you click here, should because we zoom here and there is already 9 here. So go all the way to 9 and see, you get that line pass. That's the Carl Pearson regression line, so least square method, and I hope that is there. Okay, so let's do and likewise you're going to do the same thing, scatter plots, coefficient, all these four place decimal. See, make sure this one is the same thing. Basically, let's see. This one it ask you. Let's see. If I want to find this one curve weight. So curve weight and braking distance at 50 miles per hour on dry pavement were measured for 5 vehicles. So these are like 5 vehicles whose weight is given in hundreds of pounds. And from the time it starts, let's say traveling at 50 miles and put a brake, how long, how far does it go? Is there a relationship between this? And you can see, yes, the heavier the vehicle is, you'll see the distances after braking is more. So the first part is find the linear regression line for this. Uh, is you're going to do the same thing, put the stat, all these numbers, and linear regression. And only thing they're asking you the meaning of what is the interpret the slope in terms of application. So I would like to really do this quickly. So let me clean this part. And I click 4 to clear that. Open second L1, comma, second L2. Close it. So I'll clear and enter. Go to stat and go to edit. Put those first value is 25. So 25, 27.5, 32.5, 35, and 45. So there are 5 of them. Then the next one is how the distance the vehicle travels after braking. So 105, 125, 140, 140, and 150. So all numbers are put. But the first question is find the linear regression line, right? And 4 places. So all you do is stat, go to calc, go to the linear, and there you get the answer. See, so simple. That's not only thing you have to understand also the line. I like to use this. Go to var, right click, and enter 3 times. And you get the whole answer. See, you already got A. So in the problem, okay, so in the problem, they're asking you to round four places decimal, right? So you'll have to write y is a is 1.9897. I'm round it to the fourth place, and then x, and b is plus 66.3402. Okay, so this is the regression, like linear regression, and four places are done. Interpret the slope. What is the slope? Here, the m is the slope, which is 1.9897. It means every time the weight one. So this is the weight. The denominator is the weight, and this is the distance the vehicle travels after braking. So every time you increase by one, because this is given in 100 pounds, so 100 pounds, it means whenever the weight of the car is increased by 100 pounds, because one means 100 pounds, the distance travel is almost like two. I think this gives you 2 feet, right? So it's in feet, so that's like round it to 2 feet. So that means the distance uh, the stops is increases by 2 feet. So that's what it is. So whatever the previous, if this was the vehicle, after braking this vehicle, it goes till here. And if the vehicle is a bigger one, this may go till here also. Like that. That's all it means. It increases. So this distance increases by 2 feet. So this is 2 feet from here. That's all that means. Then if the car is saying 300 pounds, can you predict braking distance? Oh, that's called braking distance. This is braking distance. All you do is look at this. Now you have to do calculate. This is a better one. Is three. When you say 3,000 means it is 30. You have to, because the x is in hundreds, so you have to put three instead of 3,000. See, they gave you 3,000 here, right? 3,000, but since 3,000, basically we are using 30. 30 means 30 hundred. See, this x is in hundred. What is this means? It's 2,500. See, this means 2,500. And the next one, if 545 means 4,500, right? So I hope that takes care. So all you do is sometimes let's try first. I think we forgot to graph. Did we graph this? Hmm, tab plot. It's on. I think we forgot to do this. So you put it on and you go enter, enter, go down, 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 and enter, and graph. See? Oh, something. I think I have to do zoom set 9. And there it is. Okay. So now we need to know, click on the trace and then enter 30. This 30. You put 30. No. No, I think I have to go back to graph and second calc value and put 30. I think it should give you the answer. See? And but if I use bigger than 45, maybe 50, let's put it second calc and put 50. Oh, see, this doesn't give you because it's outside this maximum 45. So what you do next in such case, click second mode and we'll go to the table directly because we already set up the table. Uh, the minimum is 25 here, so you can set up this table set and make it 25. So that's the minimum we have. Or maybe try 20 is better. Clear and put 20. And here, this is what you want to ask, and then you get the answer. Enter. And then click second calc. I mean table. And you can see just plug in whatever the value. If I want to write 45, 50, okay, you get the answer. If I write 55, you get the answer. If I write 20, you get the answer. So that this way we can also figure out. So that's all the question was asked about the C part. So this C part here. Okay. Would it be appropriate to use a regression line for braking distance of a vehicle for 40? No, yes, 40 is because 40 is between the range of this. See, that is okay. So that's what it's asking you is uh, just wanted to show the understanding piece here is this is the one. So the problem was this one, yeah, the curve distance, braking distance. Okay, there it is, 13, right? So the question was, would it be appropriate to use the linear regression line to predict the braking distance of a vehicle curve with the V? So what is this basically means your x is 40. Now 40 is between 25, and you say yes, this is positive. This is called interpolation. It is within the range of the x, the weight of the vehicle. So this is okay. But if the same thing was, let's see, 50, no, this is not okay because 50 is more than, so that's the extrapolation. Even though calculator does the job, but it's outside. So I hope that helps. Let's do another one, and this is the same thing. This is about height at age 2 and y at, so the height, these are both heights, but the first row is when the child is 2 years. The second one child is 20 years. Is there a linear regression? So the same thing you do like this. Well, let's see if I have time, I will do. Okay, this is question number 14, and let's put all these numbers in decimal and answer the question again. To those who are still confused, I'm showing you yet one more time. You need to clear this, so go up all the way to 4, click 4, and I think I don't want to delete. Let me do one more time. So stat, go down, enter, and open parenthesis, and second, and go all the way to L1, comma, second, L2, close, enter. Okay, done. Now you go to stat and enter, and you put the numbers again. Left, and it starts with this is the height of a child. The starting is, there are 11 children, I think. There's the 1, 2, 3, 4, 5, 6, 7, 8, 10 children at the age of 2. What was their height? That's what this tells you. So let's put those numbers 31.3. So it is 31.3, enter, 31.7, 32.5, 33.4, 35.2, 35.2, then 35.8, 32.6, and 34 points. So these are the height of 10 children who were at the age of 2. So enter. So you got, now let's go back and put, I want to make sure we have everything. 31, 2, 3, 4. I think I messed up somewhere. Okay, 1, 2, 3. I think this should be two times. I missed something there. So 32.5 and 33.5. So that's the one I missed. And next is 34.4, 35.2, 35.8, then 32.7, 33.6, 34.8. So we have 10 of them. So let's count. 1, 2, 3, 4, 5, 7, 8, 9. Again I missed. Ah, 31.3. This is correct. This is correct. And 32.1. This is correct. 34.4 correct. 35.2. Oh, I missed 35.8. 35.8. 32.7. Okay. So now let's go back and put the other numbers. The child is become big. That is 20 years old. So it is 60.7. Okay, so once you have all this done, let's find the scatter plot. So how do we do scatter plot? So make sure this is second, this, go here, enter, there you go. Make sure this is on, then go down. If it is not on, if your calculator is showing this way, then you have to click on the left and enter, go all the way down and enter. And make sure zoom in to the stat because this is the one you have to go down all the way to 9. And see, this is and there's a strong correlation. See, what that means is the height at the age of 20 increases, and from so there is a strong correlation from 2 years to 20 years. See how nicely it shows. Then what they're asking you, find the linear regression line, right? So for that, we have to click on Stat, Calc, go to linear regression, and we get the answer. That's not much. Only thing you want to make sure you save this. Over here, you have to click VAS and right click and then enter so that already comes there and enter now. See all the answers, that's the equation. So here the equation is okay. So the equation is y is a is 1 point and it says 4 decimal places 1.743 and 7 x, that's the slope, and the b is 5.9694. So this is the regression line. And the question is asking what is the meaning of the slope. So this is the slope, right? So we need to know what is the slope. And slope is basically 1.7437 divided by 1 every time. And remember, this is the when the height is the age of 2. So this means is so the down part is the height of the age 2 years, right? So it only means uh, it means for each 1 inch increase in the height at age 2, we expect on an average the height at age 20 to increase by 1.74 inches. That's all it is. So if the height increases by 1 inch, then at the age 20 it increases by 1.74. That's all that means. And C is use the linear to predict the height at 20. At 2 it was 25. I think it's asking you is is the one that is outside the number. See the 25 inches. So it means you could also do like this 37 times 25 and get the answer plus 5.96. And you put this on the calculator, you can get the answer. See, so we could write it at 1.7437. So let's put it 1.7437 times 25 plus. Okay. You could do manually also and get this answer. Uh, Even though you may get the answer to this part, you may get the answer 49, but this is not appropriate because the number 25 is outside the range of the height of these 10 children. See, so that's not a correct. This is called extrapolation because that's not the right. Even though you may get the answer, but that is inappropriate because this is valid only for this axis. The next question asking 35. It means instead of 25, we can put 35, and you can put the same thing backspace and bring it down, enter, and put instead of 25, see, we put 35, so 3, 5, there you go, and enter. We get 66.9, which we can round it to this answer. So this answer you get 66.9, which is 67. We can round it as 67. I hope because 35 is so there's the 35 here, that is big one. And this 35 is still smaller. It is in the range of that. So we can still figure out that. Another way to do this is also since I this one already has this, we can use the table set or you see this table here, click second table and I don't want those things. Oh, we want, let's see, 35, right? Put 35 and enter, and you get the answer. So that's how you got 66.9. Okay, problem number 15 talks about age of a person. These are the age of a person, 10 of them, I think. 1, 2, 3, 4, 5, 1, 2, 3. Okay. And age and the heart rate. So this number, is there a correlation between the as the age increases, what happens to the correlation? So what I'm gonna do is go to stat and then clear the old one. Okay, so that you guys already know what to do. Open parenthesis, second L1, comma, second L2, close it, and enter. It goes, everything is done. Go to stat, edit, and let's put the numbers in the first one. So it is 20, 23, 30, 37, 35, 45, 51, 55, 60. And so that takes care of the upper. Then go back and put the other numbers. 72, 71, 73, 74 is twice, then 73, 72, 79, 75, 77. And there you go. Once you do, go to the second, this, and enter, and go down, 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 and zoom, and 9, because you want to have zoom stat, right? So click, and that's it. Now this one is the old one which we have to kick off. See, we don't want this. That's the old one. So let's go back to stat plot and enter. Okay, and go down, 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 down. Oh, so I think I forgot the blinking to put it on. So this is enter, and now you go down. So second stat, click on this one, go all the way, enter, or you have to click on zoom and go to zoom stat. You see the graph. So that not there is a weak correlation. So it's not strong, but they are scattered. And you can find the coefficient of correlation here also. And how do we do that is click on the stat, then calculation, go to linear, and now you need to save this. So was, then right click, enter, enter. So and now and then you get all this. You get a coefficient of correlation also, not just so if you see this 15, so you get, I don't know why this is coming like this. Anyway, can I write at least? Hmm. Uh, with my calculator, everything got mixed up. Okay, and I have this over here. And I want to, now I have to write on this. It's not okay there. So your equation is, so the question was find the linear regression, right? So this answer is y, and it says 4 places. So a is, in the calculator, a is 0.1140x, and the b is 69.2. That is done. Second, what is the meaning of this? It's asking what is the meaning of slope. Now the slope is this piece, right? The a part. So the slope m, which is, it means if for every one, so each increase, so the bottom piece is one. If the age is increased by 1 year, for every time the person, whoever the person age is increased by 1, that means the heartbeat increases by 0.1. So we have to make sure you guys get this interpreted as slope. The right English words would be the slope. It means for each 1 year increase in age. So for each 1 year increase increase in age, we expect we expect on an average, the resting heart rate to increase by 0.11. Okay, that's all it means. But we have two more questions is what about to predict the heart rate of 25 years? Now this 25 is right here. So what we can do is, oh, we forgot about coefficient of correlation here also is given. Coefficient of correlation is R, and that is 0.070. And this number is, I would say, not strong. This is actually called moderate positive correlation. I would say if it is 0.75 and till 1, that will be strong positive correlation. Okay, I hope that helps. And I think I'm almost done. The video is too long. You can fast forward. You don't have to watch everything, but to those of you who get confused, this will have now 15. Oh, that was the last one. But there are questions like this multiple choice question. Look at this question. So there is, let me take this off. We are done with this calculator and I'll increase this. So exercise. So look at the exercise here. Okay, so this question is asking us for a certain class the relation between the amount of time spent and the test grade examined, right? So that means if you try to make two columns, so the time spent and the score in the test. So the more the time is studied, let's say somebody spends only half hour, another 1 hour, 1.5, 2 hours, 2 point, and you'll see the more the person study, you'll see the scores are getting higher. So there is a positive correlation here. There is a positive. So that means the more the dots will be like this. So this is how it will be like this. See? So so these are the scatter plot would be where as the number of time is amount of time spent in studying, you see the score also going up. That's all that means. Let's take the next one. Second question says for the same relation between amount of time spent studying and the amount of time spent socializing per week. It was determined that the hours they spend studying, fewer hours they spend socializing. So what does this mean? The amount of time spent. Let's see if this is the 0.5, 0.5, 1 hour, 2 hours. So this is like 1.5, 2. This is the time spent in studying. Time in studying, right? And this is y-axis is you're spending time in socializing. Time spent here in enjoying. I would say socializing means enjoying. That means there is a negative correlation. That means the less time is spent means maybe more time was spent here on the socializing. Maybe point like so it could be like this. So it will be point like this. See, so this is called negative correlation here. See, like this. So the more time you spend, the less time you spend on socializing. So this is negative correlation. So the truth two variables. So the x is time span in studying, okay, and y is time span in socializing. There is a correlation. Socializing. There is a correlation between the thing, and they are correlated. That's the main thing. They didn't give us any example whether it is a strong or weak. That's not an issue. The issue is there is a correlation which is negative. If one increases, the other one decreases. Let's go to the next question. In each, you have to the x is given and y is given. Like how this example x and y, or you have to say whether there is a positive correlation, negative correlation, or there is a zero correlation. Let's see the first one. Now, x, the number of. Let me pull out a new page. So the first question is the number, the number x of pages, or the x number of pages in a book. Or let's see, this is a book, right? And is the relation between this and the age, the person, whoever the person is reading. So this is the x and this is the y. Now, book is uh, what is asking is if there are less number of. Let's see, this is a skinny book. So does this mean the author is is young? Is he young? That's the it means the more the pages like this, that means he's he's become old. The older he is it like this? So that is the question. Or is it the number of pages increase then the author is younger like this? So is it? But remember that this number of pages the book has, or and the author is writing, there's no correlation between. So you here we say there's no correlation. Doesn't make sense at all. How many books, how many pages the author writes? Okay, or the second part. So this is a little confusing. I hope it makes sense to you. Let's clear this. The number of books and the age of the intended reader. So this makes sense. Let's say that there is a child which is at 8 years. So the book will be intended to number of pages will be less, right? This will be, let's say, maybe 20 pages only, and the child is 12. That's the this increases is, let's say, pages is 50, and the age of the child is maybe 15. And if the book is little bigger, 100, so there is a relation between these two. The child maybe is 21, I mean, you. So there is a positive correlation here. Here you can see there is a positive correlation between number of pages and the intended reader. When I say intended reader means how old is he? And next question is, see the weight of X of an automobile and the fuel economy Y. That means, let's see, if this is the car, which is a small, tiny car, and if this one is a bigger car, and if this is the bigger vehicle like a truck, let's say, we can see this will give more mileage. So less weight will be more mileage, more mileage. This is little bigger size, so this will become uh, still more or less mileage than the previous one. And if it is a big truck like this, the big one, the huge one, then you see this will give less mileage. So there is a negative correlation here. What is negative correlation means? The the more the weight of the vehicle, then the amount of economy or fuel economy decreases. As the weight increases of the car, the fuel economy decreases. That's all that means. Remember about this, the weight of and the reading Y of its odometer. So this one doesn't have nothing to do with the odometer, right? Because The weight, how much the car, how much the car weighs, this one or bigger or a little bigger. And the person who is driving, sorry, the reading odometer doesn't have nothing to do with. Okay, the reading odometer is will be like just driving the car vehicle. So there's no correlation here. This is no correlation. Oh, the last question is E. The amount X of a sedative a person took an hour ago, and the time Y it takes them to respond to the stimulus. What it means is how much you consume 1 hour back. Let's see, 500 milligram maybe, 1000 milligram. That's like this is like a zero point 0.5 gram. This is like 1 gram. Okay, this is like 1.5, 2 gram. So the faster, the more you took, and you will see how much time stimulus means uh, time it takes them to respond means the sedatives which are given are more if the time then this will be taking a little longer. Suppose you have a 500, it will take more time for the sedative to get effect. So this will be something like this. So this is negative correlation.